All right, so this is going to be the last part of our notes for chapter 10. And then the last section is going over composition and being able to calculate your empirical and molecular formulas. So again, I sent those notes out to you. And what I'm going to do, I'm going to just kind of highlight some things on there. Again, atomic weight, formula weight, percentages, things that we've all dealt with before. We're just going to apply them to doing formulas. Another thing that when you're doing percent compositions, 2 or 3 or 4 things, once you've figured out 2 or 3 of the items, if there's 4 of them, you know what the 4th one's going to be. Okay, they always have to add up to 100%. So when you look at that first example, I had you calculating the amount of carbon, hydrogen, and oxygen, and I only did carbon. So when you're looking at your notes, you still need to do oxygen and you still need to do hydrogen. Okay, when you're done, those 3 percentages should add up to 100%. So when you do your percent of oxygen, it should be percent oxygen would be 22, okay, times 1 AMU divided by 342. Then you would do oxygen, which would be 11 times 16 divided by 342. All of those multiplied by 100%, you would get your percentages. Again, that goes along with your notes. So you got to have your notes too, guys, if you know when those get sent to you. And then you get your empirical formula, the lowest whole number ratio of elements. We know that when we do ionic compounds are always in their empirical formula. And a trick on this one is when you are given problems, such as in your 10-2 practice problems, and I will be sending out a little video on some of those too. If they give you percentages, let's just turn those percentages into masses. Okay, and I did do that as an example when we did the mercury 1 chloride example that's in your notes. I went through the 4 steps showing, okay, let's just assume we have a 100 gram sample, so 73.9% becomes 100 grams, or it becomes 73.9 grams. Chlorine becomes 26.1 grams. We then have to get what is called the molar equivalence, or the molar value. That's the way we can compare them. Moles is our kind of that middle linchpin, and when we have that, we can compare apples and oranges now. It's totally legal to compare things that are different as long as we have a unit that lets us link those together, and the mole lets us do that. When you get down to step number 3, it says you then divide by the lowest mole value, the smaller value, and you get a ratio of mercury be divided by itself, so you get 1. Chlorine is 1.99 moles, so we round that up to 2, and you get a formula of HgCl2. Molecular formulas can be derived from an empirical formula. The biggest trick on this one is that first little bullet in your notes, that molar value, or the molecular weight, or the molar mass of the compound, of the molecular compound, has to be given. It has to be in the problem. And you'll see that in the example of mistylene. I give you the empirical formula, and then I tell you that its atomic weight, or its molecular weight in this case, was 121 atomic mass units, and you go through the steps. Step number 2 shows you how to get your multiplier, and that's all that number is. It's a multiplier. And then you multiply that number by any of the subscripts that are in your empirical formula. And then the one that I have for you to do was ethylene glycol. You have both the answers, A and B. The answers are there, so you had to work towards them. So I thought I'd go through and do that one and just set it up on my little whiteboard here. And we will do the whole thing. And that way you can see it done. And you can have your other ones that are on the notes that you copied out yourself. So in this one I said, okay, we're going to start off with ethylene glycol, the stuff that's in antifreeze. And there is 38.7% carbon. There is 9.7% hydrogen and 51.6% oxygen. Okay, so these are percentages. So the first thing I'm going to do is say, well, I'm going to say I just have a 100 gram sample of this substance. So this now becomes, I have 38.7 grams of carbon, 9.7 grams of hydrogen, and 51.6 grams of oxygen for this compound that I'm trying to figure out its empirical formula. So I can now say, well, since I did that, I can get rid of those percentages and get them out of the way. And I can do some more work here. So the first thing we have to do, and I'll come back to another part here in a moment, is let's find our molar equivalents. How many moles of each of these do I have? Well, to do that, I need to know the molar mass of carbon. So if I have 38.7 grams of carbon, I need to get its molar mass of carbon. And I do that by saying, okay, 1 mole of carbon is 12 grams of carbon. 9.7 grams of hydrogen. 1 mole of hydrogen is 1 gram of hydrogen. And 51.6 grams of oxygen is 1 mole. Oxygen is 16 grams of oxygen. Again, I can cancel out units. And again, I highly recommend this. Those of you that are sending in work, you have little notes on your email saying make sure you show all your work. So we do this 38.7 divided by 12, and I'll look at my little notes here. We get 3.22 moles. 9.7 divided by 1 is really easy. That's 9.7 moles of oxygen. And then I also get down here 3.22 moles of, not oxygen there, sorry guys. I have to say hydrogen. Okay, now we do the second part is we have to divide by the lowest molar value that we have for our mole ratios. So 3.22, 3.22, 3.22. Just divide by all of those. And this gives me a mole ratio of 1 mole. This is going to be 3 moles. And this is going to be 1 mole. So your answer for A, which is on the paper, is CH3O. That's my empirical formula. And I got that by doing my mole ratio, figuring out what the lowest value of my mole ratio is, and then dividing everything by that lowest value, whatever it is. If you do get a value, you know, if it's 2.9, we round it up to 3. If it's 3.1, we round it down to 3. Okay, that's going to happen. There will be some instances where once in a while, if we get a mole ratio that is 2.5, 3.5, anytime we see this 0.5 again, just like what happens when we did our coefficients, we'll multiply everything by, guess what, 2. And then we can increase those. So that's just a little hint as to something that you may have seen on your 10-3 practice problems, and I will get on our next little video. So if you saw something where, hey, I came out with my mole ratio, one of them was 3.5, do I round that up or round it down? Well, it's really not safe to do either. We should multiply it by 2 and get a better value, get a closer value to be more precise. So let's come back to this problem. We got A done. We figured out our empirical formula. So another thing that was given in the problem, it says that the molar mass of ethylene glycol, so the molar mass of ethylene glycol is 62.1 grams per mole. That's a given value. That's what this real compound is. Whatever the real CHO, we got to fill in those, whatever that is, weighs this much. So how do we do that? Well, to find the multiplier, we are going to take our molar mass that's given divided by our empirical mass, which we have to calculate, which is going to be 12 for carbon plus 1 times 3, because we got 3 hydrogens, so we got to multiply that by 3. We can put grams here for these. And oxygen is 16. And if we add that up, we get what? 3. So 9, 5, 11. This becomes 31 grams. So the empirical mass for this is 31 grams per mole. We then plug that value into the bottom here, 31 grams per mole. Grams per mole cancel out, and this you can pretty much do in your head. 62.1 divided by 31 is going to give us a multiplier of 2. Yes, I know it's going to be a little less than 2, or a little more than 2, but that's fine. Okay? Our multiplier is 2. So if this is my multiplier, I have to apply it to my empirical formula. So 2 times 1 is 2. 2 times 3 is 6. And 2 times 1 is 2. And your second answer for part B was C2H6O2. So if you calculated it out and got those answers, that's how you set this problem up. If you look at the notes, they go through it step by step for your empirical formula, for your molecular formula. Go back and look at your percent composition. I broke them all down in your notes step by step. You just work it the same way every time. All right, so be expecting another little video tomorrow. Make sure you're working on your lab that I sent out today. That was on formulas and reactions. So you got to name them again. I don't think I put it on the test, but you can even tell me what kind of reactions they are. If they're single replacement, double replacement, that'd be great too. Just add another little layer to it so that you're practicing that work from chapters 8 and 9 that we did. All right, so I'll talk to you later. Make sure you email me if you got questions. We've got another quiz tomorrow, another mold quiz coming out. Okay, trying to get ready for another test sometime here in the very near future. A little take-home test again. I'll talk to you later.